So yes, today we are going to start some important question of chapter 1, chemical reaction and the equation. Okay, so let's start with the same. Yes, so the chapter name is chemical reaction and the equation, chemical reaction and equation. So I am asking the first question, of course. Okay, if I see, why do we need to balance the chemical reaction? Why? If I say, like people say, so whenever anybody asks, like, why do we need to balance the skeletal reaction? Skeletal means unbalanced, right? Skeletal reaction meaning is unbalanced reaction. Okay, as I already told you. So that's why we have to make them balance. So we can, why should we balance them? Because we have heard about that conservation of mass. So to maintain that conservation of mass, that's why we always have to balance that. And I guess we already know that matter can neither be created nor be destroyed. So that's why if at the left side, it means reactant side is something. So you have to maintain that at the right side too. That's why we have to maintain that. Now, suppose if I say that, suppose, um, like sometime they will ask you, you have to write down the reaction of the photosynthesis. And you have to tell me, is it a redox or not? Of course, it is a redox. And so if I say, like we know that green leaves usually take the carbon dioxide and they need water also. Not only carbon dioxide and the water, but they also need what? Sunlight and the chlorophyll, right? So in the presence of sunlight and the chlorophyll, so they will form what? They will form the glucose, and glucose formalizes C6H12O6, and they will release oxygen gas. And that's why we say save the plant, save the life, because we are getting the oxygen. So how can we balance them? It is C6 now, so we directly have to multiply by 6. Here it is like H12, so we can write down 6 here so that it become 12. And of course here oxygen are 18. So to balance that we have to write this 6 here, so that it also become 18 oxygen. So now this reaction is completely balanced, yes or no? So this is a complete reaction of photosynthesis. And from carbon dioxide, like there is a addition of hydrogen, so it is a reduction actually. Okay, so carbon dioxide is being reduced here, so it is a reduction. So in the photosynthesis, what will happen to carbon dioxide? So remember that it is being reduced to the glucose. Next question is, like desert plant usually take up the carbon dioxide and perform the photosynthesis, but they have some different phenomena. So what is that phenomena? So actually, in the desert plant, we usually call them CAM, crassulacean acid metabolism. Okay, so crassulacean acid metabolism, what does it mean that? So their stomata opens at the night. Do you know, like biologically, if I talk about, so on the leaves, mesophyll cells, they have a stomata, right? So these stomata help in the exchange of gases, isn't it? So if these stomata are going to open at the daytime, so it may get damaged. So that's why these stomatas are going to open at night time so that it won't get damaged by the sunlight. So that's why they exchange their gases at the night time only. So in desert plant, stomata are open at the night time, and they take CO2 at the night time, and they store as a acid like carbonic acid, and then they utilize it in a daytime. Okay. So this is what happens in the desert plant. CAM means crassulacean acid metabolism. Crassulacean acid metabolism. So now the next question is, suppose if I say you have a slaked lime and if you have a H2O, okay, so CaO and H2O, it is giving the calcium hydroxide. So what type of reaction is this? Combination, decomposition, double displacement, or what? Two reactants are going to combine to form a single product. So yes, so of course it should be a combination reaction. Okay, so this is known as a combination reaction. Why? Because two or more substances are going to be joined together and they are forming calcium hydroxide. So this is a combination reaction. Very simple it is. But suppose if I say if you have a barium chloride. So barium, I already told you barium has a valency of 2 and chloride has a 1. So when you cross, so it will become the barium chloride BaCl2. Okay, what is the formula of aluminium sulfate? Anybody? Aluminium sulfate. So sulfate has a valency of 2, aluminium has a valency of 3. So when you cross them, so what should be the formula of aluminium sulfate? Al2SO4 thrice. Yes. So Al2SO4 thrice. So it is giving you what? So it is giving you BaSO4, isn't it? Ba is combining with the sulfate. Okay. And why it is only by barium? Because barium is valence is 2 and sulfate has a valency 2. So 2 and 2 cancel out. So it will remain as it is 1 1. So that's why it is a BaSO4. And that will become what? Al, aluminium and chloride. What is the formula of aluminium chloride? So we know that Al and chlorine. Al has a valency of 3, chlorine has a valency of 1. So what should be the formula of aluminium chloride? AlCl3. So is it balanced now? No, aluminium is 2 here, but here is only 1. So we have to multiply by the 2. So now it will become 2AlCl3. And here barium is how much? See, chlorine is total 6 here. 2, 3 just 6. So total chlorine is 6. But here chlorine is only 2. So of course we have to multiply by 3, right? And if we are multiplying by 3, so of course we have to multiply by this 3. So now it is completely balanced reaction, yes or no, everybody? So now it is a balanced reaction, not the skeletal one. What type of this reaction is this? Combination, decomposition, displacement, double displacement, redox. What kind of reaction is this, everybody? So this is actually double displacement reaction. Why? Because ions are getting exchanged here. Because ions are getting exchanged, so it is a double displacement reaction. But but this reaction is not only double displacement. This reaction is something else too. Can you tell me that? So yes, of course, this is barium sulfate is aluminum chloride. So this is also a precipitation reaction, okay? Because we are going to get precipitate here too. It is an example of precipitate reaction. Okay, so that's why. Okay, if we have a ferrous sulfate, okay, and ferrous sulfate, if we are heating it up, if we are heating the ferrous sulfate, so actually it is going to give you ferrous oxide like Fa2O3 plus SO2 and plus SO3. So of course we have to balance this reaction. So 2FeSO4 on heating, we are going to get Fe2O3, SO2 and SO3. Okay. So can anybody tell me what kind of reaction is this actually? So yes, as it is taking up the heat, so by taking up the heat, it is going to be broken. So yes, this is decomposition. But what kind of decomposition is this? Because I told you the three types. So of course, as it is, so it is taking up the heat. So this is known as a thermal decomposition. Good. Thermal decomposition. And it is taking up the heat. So that's why it is also known as a endothermic reaction because heat is being used up here. And when the heat is being used up here, so that's why it becomes the endothermic reaction. Now, I'm just writing certain reaction and we have to tell what kind of change we are observing. Or suppose if I say we have to tell a reaction in which color is getting changed only. So like we have to conduct a reaction and we have to see the change. So yes, so actually if I tell you like copper, so copper is actually what? It is blue in color. But when we add silver nitrate in that AgNO3, so when we are adding AgNO3 in that, okay, aqueous AgNO3 actually, so what will happen? So it is going to form copper nitrate. Copper nitrate valence is 1, copper is 2, so that's why it will become CONO3 twice. Okay, plus, and the Ag will remain as it is, like Ag. So copper nitrate, and it will form the 2Ag. So this solution will become actually like it was already blue, and now it will become a silver kind of surface, like shiny silver. Oh, sorry, not because of this, but because of this. Because this is silver, na, Ag. So it will have a shiny silver surface. Okay. So that's why can we say that? So it was blue in color, and now it has a silver, shiny silver surface. So it is a result of change in color, yes or no? So yes, so copper was blue in color, and right now it has a shiny silver surface because of this Ag. So it is a result of change in, I mean, it is an example of change in color. Okay, sometime they will also ask you, can you tell us the reaction in which change in temperature is happening? Change in temperature is going to take place. Yes, we can say that. So can we say that in which heat is going to release, in which heat is going to be evolved? So of course temperature would be high. So of course there is a neutralization reaction. When a acid means HCl, and there is a base, most common NaOH, sodium hydroxide. So when a acid and a base react with each other, so it is going to give us the salt, and it is going to give us the H2O, but it will also produce some amount of heat. Okay, and because heat is being released here, so this is known as a exothermic reaction. But can we say that it is an example of change in temperature also? अगर हमसे क्वेश्चन बोला जाए कि आपको प्रेसिपिटेट बनाना है, तो मैंने प्रेसिपिटेट की ऑलरेडी रिएक्शन लिखवाई है, राइट? जैसे ये मेरे पास प्रेसिपिटेट है, ठीक है, प्रेसिपिटेशन रिएक्शन। लेकिन अगर मेरे से बोला जाए कि आपको एक्चुअली लेड का यूज करके प्रेसिपिटेशन रिएक्शन बतानी है, तो प्रेसिपिटेट रिएक्शन मुझे बतानी है जिसमें किस चीज का यूज हो रहा हो, लेड का। तो अगर मुझे एक ऐसी प्रेसिपिटेट रिएक्शन बतानी है, तो मुझे लेड का यूज करना है, तो ऑफ कोर्स आई नो इट वेरी वेल कि मेरे पास क्या होता है। मेरे पास जैसे आई कैन आई रब दिस, यस। तो मान लो मेरे पास ना एक लेड नाइट्रेट है, तो नाइट्रेट की वैलेंसी तो भाई 1 होती है, और लेड की मेरे पास 2 होती है, तो फॉर्मूला क्या बन जाएगा? तो फॉर्मूला वुड बी PbNO3 ट्वाइस, इजंट इट? तो ये मेरे पास लेड नाइट्रेट होगा। तो अब फिर मैं बोल सकता हूँ लाइक दिस इज लेड नाइट्रेट PbNO3 ट्वाइस। तो मेरे पास ये PbNO3 ट्वाइस है, लेड नाइट्रेट। और जब मैं इसके अंदर पोटेशियम आयोडाइड डाल दूंगा, Ki, तो मेरे पास क्या बनता है? तो मेरे पास बन जाता है PbI2, लेड आयोडाइड PbI2, क्योंकि आयोडीन की वैलेंसी 1 होती है, Pb2। और ये बन जाएगा KNO3, पोटेशियम नाइट्रेट, क्योंकि दोनों की वैलेंसी 1 होती है, इसकी भी और इसकी भी। तो KNO3। अब ये PbI2 बना है, तो बट बैलेंस तो है नहीं, यहाँ पे 2 लगाना पड़ेगा, और यहाँ पे भी फिर 2 तो लगा हुआ ही है, ठीक है। और ये फिर NO3 ट्वाइस है, तो यहाँ पे 2 लगाना पड़ेगा। सब कुछ बैलेंस हो गया, इजंट इट? तो इसका मतलब मेरे पास ये जो मेरे पास PbI2 बना है ना, तो ये लेड आयोडाइड बना है, और लेड आयोडाइड का कलर कैसा होता है? येलो इन कलर। सो ये जो मेरे पास एक पीपीटी बना है, इट इज येलो पीपीटी, ठीक है, लेड आयोडाइड, एंड वी हैव टू रिमेंबर दैट। सो लेड आयोडाइड इज ऑलवेज इन येलो इन कलर, और लेड नाइट्रेट के अंदर अगर हम Ki डालते हैं, तो इट विल फॉर्म दी PbI2 and KNO3. So this is also an example of precipitate reaction, okay, in which Pb is being used. So we always have to remember this example too. It is important for the board examination. कभी कभी में इस बोर्ड के अंदर एक क्वेश्चन ये भी आता है कि एक ऐसी रिएक्शन लिखिए जिस जो फोटोग्राफी के अंदर यूज होती है, और सनलाइट का भी यूज करती है, तो ऑफ कोर्स मैंने बताया था, राइट? तो हमारे पास फोटोग्राफी के लिए कौन सी चीज यूज होती है? कैन वी से दैट AgBr? तो जब AgBr जब हम सनलाइट के अंदर रखते हैं, तो ये क्या बनता है सनलाइट में रखने से? सो इट विल फॉर्म Ag+Br2, क्योंकि Br कभी अकेला तो निकलता नहीं है, तो ब्रोमीन गैस के फॉर्म में निकलता है। तो ब्रोमीन गैस की फॉर्म में निकलेगा, तो यहाँ पे 2 लगाना पड़ेगा, बैलेंस। अब Ag भी 2 हो गया। तो दिस इज माई बैलेंस रिएक्शन, अ रिएक्शन विच इज यूज्ड इन दी फोटोग्राफी, राइट? So we always have to remember that. और कभी कभी मेरे से एक ये वाला क्वेश्चन ये पूछा जाता है कि मान लो अगर आपके पास फेरस सल्फेट है, तो फेरस सल्फेट को जब आप हीट करते हो तो ऑफ कोर्स ये एंडोथर्मिक हो गया। तो मेरे पास थ्री इंपॉर्टेंट प्रोडक्ट बनते हैं, और ये क्वेश्चन बोर्ड का बहुत ही फेवरेट क्वेश्चन है। तो वो प्रोडक्ट कौन से हैं मेरे पास? रिमेंबर दैट। सो दीज प्रोडक्ट शुड बी, एक बनता है मेरे पास Fe2O3, एक बनता है SO2, और एक बनता है मेरे पास SO3। ओके, तो ये जो मेरे पास बना है इसको हम क्या बोलते हैं? दिस इज कॉल्ड फेरिक ऑक्साइड। ठीक है, आयरन ऑक्साइड भी बोल सकते हो। तो दिस इज फेरिक ऑक्साइड, दिस इज सल्फर डाइऑक्साइड, एवरीबॉडी नो दैट, सल्फर डाइऑक्साइड, राइट। और ये मेरे पास क्या है? सल्फर ट्राइऑक्साइड, राइट, इजंट इट? सो ये बहुत ही सिंपल रिएक्शन और बहुत ही इंपॉर्टेंट रिएक्शन। तो ये अपने आप में डिकम्पोजिशन रिएक्शन भी है, ये अपने आप में थर्मल डिकम्पोजिशन, और ये हीट भी ले रहा है, तो ऑफ कोर्स एंडोथर्मिक रिएक्शन भी हो जाएगा। वेरी वेरी सिंपल इट इज। ओके, तो ये चीज हम लोगों को याद रखनी है। और एक चीज और, ये जो फेरस सल्फेट होता है ना, तो ये मेरे पास एक्चुअली ग्रीन कलर का माना जाता है। दिस इज एक्चुअली ग्रीन कलर। तो कभी कभी क्वेश्चन इस तरीके से भी आता है कि ये जो मेरे पास ग्रीन कलर है, तो बाद में इसका कलर चेंज हो जाता है, क्यों? क्योंकि जो मेरे पास सब्सटेंस बन रहा है ना, तो ये जो मेरे पास सल्फर डाइऑक्साइड, सल्फर ट्राइऑक्साइड, तो इसकी वजह से इसका कलर कैसा हो जाता है? थोड़ा ब्राउन से कलर का, रेडिश ब्राउन जैसा कलर हो जाता है। ठीक है, तो रेडिश ब्राउन टाइप का हो जाता है बाद में। तो ये जो गैस निकल के आ रही है, तो ये रेडिश ब्राउन कलर की होती है, लेकिन पहले ये ग्रीन कलर का होता है। तो फेरस सल्फेट पहले ग्रीन कलर का होता है, बाद में रेडिश ब्राउन। व्हाई इज इट सो? बिकॉज इट इज अ डिकम्पोजिशन। FeSO4 is broken down into Fe2O3 SO2 plus SO2. So these are the important reaction in terms of the, like for the on the point of view of board examination. So we always have to remember that. So yes, reactivity series I just told, okay, in the class. So actually these reactions help you to determine which reaction is going to take place or which not. So suppose if you have a Fe2O3, ferric oxide, and if you are taking aluminium, so what do you think, reaction will going to take place or not? If it is ferric oxide and this aluminium, so reaction will happen or not happen? Any guesses? See, we have a complete series, right? So we know that Lala Kedarnath Bag Alu. So Alu, it means like Al is lying here, Jala Fika. So it means Fe is a line, Fe is downward and Al is above of that. So Al can displace the Fe or Fe can displace the Al. So Al can displace Fe. So it means this Al can displace the Fe, right? So it means reaction will take place. So reaction will become aluminium oxide, and aluminium oxide formula is O is 2 and aluminium is 3. So formula would be Al2O3, isn't it? Al and oxygen. Al valence is 2, 3 and oxygen is 2. So just do it cross. So if we are crossing it, so we are going to get Al2O3. Of course, iron will become like it's a like alone situation, lonely. So it's a 2Fe. And of course, some heat is being produced, okay, when this reaction happens. So it is also exothermic reaction, okay, and it is also a displacement reaction. So Fe2O3 plus Al, so it will form Al2O3 and Fe will remain as it is. So we have to remember this reaction. This reaction is very important. Why? Because this reaction is known as a thermite reaction, because heat is being produced now. So molten iron is also used for that, molten iron for repairing works, for repairing the railway works. So this iron, it is a like being produced here. So this is a molten iron because it is taking place at a very high temperature. So this is known as a thermite reaction. It is very important reaction, and it is used for repairing the broken railway track. Thermite reaction used for repairing broken railway tracks. broken. So this thermite reaction, this is very important. You always have to remember that. Okay. So now, if I ask you, sometime, yes, definitely, like these type of question I usually give in the test. Okay, and I gave that. So one difference between the physical change and a chemical change, of course, in the physical change, no new substance usually get formed, but in a chemical change, a new substance is going to get formed, right? And it has some different properties if you compare with the reactant. So a product always have in the chemical change and always a new substance is formed. Okay, and sometimes simple question is also you will see in the board exam, what do you mean by chemical reaction? So of course you will say the transformation of reactant into product, transformation of certain substances into a new substances. So this is called a chemical reaction, right? So many question you will see. And yes, sometime like there is a such type of question, like there is a solution of substance X and it is used in the whitewashing. Whitewashing. So what is the substance of this X? Whitewashing. So always remember X is a slaked lime. Slaked lime is always, the slaked lime means, can we say calcium oxide? So slaked lime is known as a, it is always used in whitewashing. Slaked lime, and it is also known as a CaO. So it is also known as a quick lime, CaO. So X is here, whitewashing. So CaO is used in whitewashing. And sometimes they will also ask you if you pass H2O in that. So you have a quick lime. So if you pass H2O gas, H2O gas, or you can say moisture, then what you will get? So you will get the calcium hydroxide. Okay, and you will get the heat. So such type of questions you will also see in board examination, like when H2 is being passed there, so you will get the calcium hydroxide and the heat. Okay, very simple it is. तो अब जो ये मेरे पास रिएक्शन मैं लिख रहा हूँ, तो इस कभी कभी रिएक्शन बैलेंस करने के लिए भी आता है। तो हमको वैसे तो ये रिएक्शन मैंने क्लास में करवाई है। तो ये मेरे को देता है PbO, NO2 देता है और O2 देता है। ये वाली रिएक्शंस बहुत ही इंपॉर्टेंट टाइप की रिएक्शंस होती हैं जो बोर्ड में हमें काफी देखने को मिलती हैं। तो ये मेरे पास कुछ रिएक्शन है, PbNO3 ट्वाइस, तो PbO प्लस NO2 और प्लस O2। तो अब अगर मैं इसे बैलेंस करना है तो व्हाट शुड आई डू? So actually if I want to balance this reaction, so can we count that the oxygen 1 4, so it is total oxygens are 5, right? But here oxygen are 6 and it is 5. So it is not so easy. So but if I apply, if I just write 2 over here, okay, so now PB become 2, so we can multiply the P like 2 here. Okay, right now so nitrogen become how much? 2 and 2 4, right? 2 and 2, so it become 4, so we can write 4 here. Now can we count the oxygen? So 2 plus 8 plus 2, so it is 12 oxygen, right, total? And here it is also 12. Why? Because 3 2 just 6 and 6 2 just 12. So everything is balanced now. Am I right? So it means we have to apply some hit and trial methods also, and we can easily balance them. So we have to remember such type of reactions. Some, of course, like basic question, you already know that, like what do you mean by the corrosion, the eating up of metal? Okay, so there is no need to tell you here, but still. And what can we do for the prevention? Oiling, greasing, galvanization. And in the galvanization, which material we use? Zinc, of course. If I talk about rancidity, so of course the smell and the taste get changed whenever oil and fat containing food is getting oxidized, isn't it? So whenever fat and oil containing food is being oxidized, so its smell and taste get changed. And what can we do for its protection? We can use airtight container, antioxidant, right? And what else? Of course, refrigerator also, right? And sometimes they will also ask you what is the formula of rust. And like in the corrosion of iron. So what is the formula of rust? Anybody? Rust formula. Fe2O3 into XH2O, because we don't know the H2 amount. So it is a formula of rust and it is quite weak. It is not so strong structure. जैसे हमेशा की तरह मैंने बताया भी है कि मान लो अगर मैंने बोला कि ये Fe2+ है और ये मेरे को क्या दे रहा है, ये मेरे को दे रहा है मान लो Fe3+, तो यहाँ पे 2+ था, यहाँ पे 3+ है ऑफकोर्स, तो इसका मतलब क्या, इसने इलेक्ट्रॉन को लूज कर दिया है। भाई पहले 2 का लोन था, अब 3 का लोन है। तो Fe2+ से इट इज फॉर्मिंग Fe3+ बाय लूजिंग इलेक्ट्रॉन। So by losing electron, whenever there is a loss of electron, so it should be oxidation or reduction. Whenever there is a loss of electron, whenever there is a loss of electron, it is always oxidation. Lose, O means oxidation, lose. So oxidation it is losing the electron. And if someone is gaining the electron, suppose if I say it is copper 2+, so now suppose it is gaining 2 electrons, suppose. So if I am writing at the left side, so it means it is gaining electron, and now it has become copper only. Why? Because 2+ and 2- it become neutral. So if it is gaining the electron, this is called reduction. Very simple it is. Okay, so you don't need to remember only in terms of oxygen and hydrogen, but also in terms of the ions. So you always have to remember that. And sometimes they will also ask you very simple question. If you have a magnesium ribbon, so when it is in AO, so what it will happen? So magnesium and oxygen, they will form MgO, magnesium oxide. And whenever we are using such device, so we such things, so we have to remove the outer layer by the sandpaper, so that we can remove the magnesium oxide layer. Suppose if you want to use magnesium for any kind of activity, so whenever you are taking out the magnesium ribbon, so you always have to remove the outer layer. Why? Because it is actually magnesium oxide, and magnesium oxide, you need actually magnesium only. So that's why you have to remove the upper layer, which is MgO. Fine. So all these are the very important question, and there are basic important question like exothermic heat is being released, endothermic heat is being utilized, what is neutralization reaction, when a acid react with the base, so it will form the salt. Okay, and water also. So all these are like basic things which we need to remember. And what are the observation in a chemical reaction? So you will say change in state, change in color, evolution of gas, change in temperature. All these are the factor by which we can easily know that reaction has taken place or not. Okay. So, and sometimes they will also ask you like what is the formula of the silver chloride, AgCl. So remember, silver chloride formula is gray. I mean it's a color is gray. So remember that, AgCl. And if I talk about the calcium oxide, so I already told calcium oxide when you are passing it with the H2O, so it will form the CaOH twice by giving the hissing sound and by giving the heat. Okay. Okay, sometime they will also ask you, like suppose if you have a copper powder in a china dish, there is a china dish, there is some powder. So actually when you are heating that dish, heating that china dish, okay, so the surface of that copper powder become coated with a black color substance. So what is that actually? It was a copper powder, but after that it become a black. So why is it so? Because copper oxide, because when we are heating it up now, so copper is actually combined with the oxygen, because heating means oxidation. They are combining with oxygen, so they will form copper oxide. So that's why that black substance is of black, I mean the copper oxide. So when the copper react with the oxygen, it will form copper oxide, which is a black in color. Okay, it means oxidation of copper has taken place. So Cu plus O2, it will form CO. Okay. तो आज के इस सेशन के लिए हम इतना ही करते हैं, ठीक है। रेस्ट ऑफ द थिंग वी विल डिस्कस इन अवर नेक्स्ट क्लास। तो हमारे पास आज के लिए हमने चैप्टर 1 लिया है 10th का, ठीक है, केमिकल रिएक्शन एंड इक्वेशन, क्योंकि अभी वही चल रहा है। तो बाकी की यूट्यूब सेशन भी हम बाद में करेंगे, ठीक है। तो साथ साथ चलते रहेंगे। तो आज के लिए इतना ही, बाकी मिलते हैं नेक्स्ट क्लास में। टेक केयर एवरीबॉडी, बाय बाय।